Okay, today we're going to look at the discriminant, which is part of the quadratic formula, and we're going to solve some equations. So remind ourselves of the quadratic formula. The quadratic formula is that if ax squared plus bx plus c equals 0, then the solutions are given by x is equal to minus b plus and minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. So we're going to solve three equations and see what happens on each one. This first equation, we can put it into the quadratic formula. We get x is equal to minus 3 plus and minus the square root of 3 squared minus 4ac all over 2a. This gives us minus 3 plus and minus the square root of 49 over 2, which is equal to minus 3 plus and minus 7 over 2. We're going to get two solutions. x1 is equal to minus 3 minus 7 over 2 minus 10 over 2 minus 5. x2 is going to be minus 3 plus 7 over 2. 4 over 2 is equal to 2. Notice we have two solutions on this one. So if we try the second equation, the first thing we need to do is to always rearrange the equation into standard form. It's not in standard form yet. This gives us 2x squared plus 8x plus 8 is equal to 0. Putting this into the quadratic formula, it's going to give us x is equal to minus 8 plus and minus the square root of 64 minus 4 bracket 2 bracket 8. That's going to be all over 2a, which is 4. And then we can get minus 8 plus and minus the square root of 0 over 4. Now the square root of 0 is 0, so we have 8 plus and minus 0 over 4. So negative 8 plus 0 is negative 8. Negative 8 minus 0, still negative 8. So this simplifies to minus 8 over 4. So we only get one solution this time. X is equal to minus 2. Our last equation, first thing we need to do is to rearrange the standard form. We can move this x across to the other side by subtracting x from both sides. This is 2x squared plus 3x. We can move the 2 across to the other side by subtracting 2 from both sides. Gives us 4 minus 2, leaving just 2 is equal to 0. Put this into the quadratic formula. We get x is equal to minus 3 plus and minus the square root of 9 minus 4 times 2 times 2 all over 4. That's going to be minus 3 plus and minus the square root of negative 7 over 4. Now, there are no real solutions to the square root of a negative number. So at that point, this implies there are no real roots, no real solutions. Now, what's happened here is we've got three different outcomes from our use of the quadratic formula, and we can see where this is happening. So in this first equation, here at this point, we're square rooting a positive number. If we square root a positive number, we will get an answer, a positive answer. We can add and subtract that answer from whatever minus b is, and that will give us two solutions. In the second solution, we're square rooting 0. So b squared is equal to 4ac. So those two cancel out inside the bracket. Here we have 64. Here we have 64. So we have 64 minus 64, giving us 0, leaving us with just one solution in this case. So here we have one solution. Here we have two solutions. last case, b squared is less than 4ac. So we've got 9 minus 16, giving us negative 7. When we have a negative number inside the square root, we can't find the square root of a negative number, and this leads us to our final outcome, which is no real roots. So summarizing that, we can look at this part of the quadratic formula, which is inside the square root, and we call this the discriminant. So b squared minus 4ac is the discriminant. We use the Greek letter delta as a shorthand for that. So if the discriminant is positive, this implies we have two real and different solutions, or we have two roots. If the discriminant is equal to 0, then this implies that both the solutions are going to be the same, so we get one root. If the discriminant is negative, this will give us the square root of a negative number, so we have no real roots. No real roots. We can apply this when testing to see how many solutions an equation is going to have without solving the equation.